First question says, which Azure service is used to provide a scalable, fully managed relational database service? In this question, we are designing a SQL database solution. Fine. And the solution will include 20 databases. Okay, that's a good number of databases we need to host. And all 20 databases, that will be 20 GB each. Fine enough. So, and they have varying usage pattern. Okay, that's also a point to be noted. You need to recommend a database platform to host the databases, and the solution must meet the following requirements. Okay, the requirements are: the solution must meet SLA or service level agreement of 99.99%. Compute resources allocated to database must scale dynamically, and the solution must have reserved capacity, and compute charges must be minimized. Move to the next question. You have an on-premise application that consumes data from multiple databases. Fine. The application code references database tables by using a combination of the server, database, and table name. Okay. Now you need to migrate application data to Azure. To which two service can you migrate the application data to achieve the goal? The next question says, you need to design a highly available Azure SQL database that meets the following requirements. Failover between replicas of the database must occur without any data loss, and the database must remain available in the event of a zone outage. And let's move to the next question. You have an app named App1 that uses two on-premise Microsoft SQL Server database named DB1 and DB2. Now we plan to migrate DB1 and DB2 to Azure. Fine. And we need to recommend an Azure solution to host DB1 and DB2. So basically there are two databases which is on premises. We need to migrate to Azure, and we need to figure out which solution is going to help them. First, we also have a requirement that it should support server-side transaction, which is fine, and minimize administrative effort to update the solution. Okay. Hello everyone, and welcome to this video of 591 Lab. I am Manny, and I am thrilled to have you here. In this video, we are going to learn about Azure SQL Database and review some questions related to AZ-305 exam. Azure SQL Database is a cloud database solution offered by Microsoft Azure. It comes under the PaaS, which is Platform as a Solution category of cloud computing. In this video, we will learn about Azure SQL Database and its features, along with few exam preparations related questions. Before we begin, let us introduce ourselves first. We are 591 Lab, and we are the top IT training and certification brand in China, Hong Kong, Taiwan, and Singapore. Our mission here is to provide our clients with exceptional exam preparation experience for certification in Cisco, Huawei, Aruba, Juniper, Microsoft, and Azure Cloud. To know about us in detail, please visit 591lab.com. Along with this, we have humble request to subscribe our channel, like the video, and hit the notification bell. This helps us to create more content like this for you. So without taking any more time, let's have a look at the agenda for the session. Here is the agenda for this video. First, we are going to learn what is Azure SQL Database. After that, we are going to create Azure SQL Database in Azure Portal. While creation of Azure SQL Database, we will talk about service and compute tier, and we will also understand what is Elastic Pool and how it is important and beneficial for the SQL database. In the last section of the video, we will review some questions related to AZ-305 exam preparations. So request you all to watch this video till end. Let's get started. As we know, Azure SQL Database is a cloud-based service. Before we learn in detail about this, we need to understand how it works in on-prem or off-cloud environment. So let's assume this setup is our on-prem environment. In this setup, when a user or client access an application, the flow works like this. From user or client's machine, the request goes to application server, and then based on the request, application server retrieves the data from the database server. So the database server is a server which actually holds all the actual data. This is the server where we have the data in form of tables, and all the tables are related with each other. Now, if a user wants to view the data, then application server does the read operation from the database server, read the data and get back to the client. However, when user wants to save the data, then application server takes that request and write the data into the tables of the database server. So to save and keep the data in database server, we need to first create a database server. To create a database server, we need a physical or a virtual machine first. Then we need to install operating system. It could be Windows, Linux, or any other operating system. On top of that operating system, we need to store or install a database engine. On the database engine, like SQL, we have given by the Microsoft. So database engine is basically a platform or a software or an application of the database. Now, after the database engine is installed, we need to create multiple database based on our requirement. So for example, if I would like to create one database for my sales department and one database for my HR department, then I need to create two databases. Now on those two databases or on those multiple databases, I need to create the tables. So tables are basically the last entity where the data is being stored, and all those tables are related with each other. That is why we also call SQL a relational database management system. So this is how it works in an on-prem environment. Since this is the setup of on-prem environment, we also need to understand few more points related to this setup. So the first point is, since this setup and manageability of all this database server is basically upon us only. All management and administration related to the database server needs to be done by us. Now we have a database server, and in that database server we have operating system as well as we have database engine. So upgradation of both these entities is also needs to be done and maintained by us only. Now we have a database server, so we also need to ensure the high availability, because this is the backend or the backbone of any application. So in order to ensure the high availability for this database server, we also need to set up a replica database server. That burden is also on us. After that, all the data is stored in this database server, so we need to back them up. So backing up all the database server and all the data in this environment is also our responsibility. So in this setup, these are the different challenges or responsibility we need to bear. Now it is time to understand how the database server is going to work in the cloud environment. We need to understand, or we are going to understand, how all these problems we talked about related to the management, administration, high availability, and backing up or backup, it is going to be remediated or solved by offering of a PaaS solution. So Azure SQL Database is a PaaS solution, which is platform as the solution service for the cloud. So let's go and understand how this database server works when we'll talk about in Azure Cloud. To understand how database server works in Azure as PaaS solution, let's look at the diagram. By looking at this, you can see we have all entities which we have in our on-prem as setup. For example, we have OS, database engine, then we have databases, and we have tables. Here in cloud, we also need all these entities. However, the entities like physical or virtual machine, and the operating system which is running on those machines, and the database engine software like SQL, all these entities are basically managed by Azure itself. Since Microsoft is managing the physical or virtual machine and its OS and the database, so we are not going to take the burden of maintaining the replica of our database. We also do not need to worry about the backup and high availability. So all those concerns or administrative tasks we have in our on-premise setup, here Azure is offering a solution for that, and that is called Platform as a Service for Azure Cloud. Here, all we need to worry about creation of our database and tables. Since we are going to create our databases in Azure Cloud, so Azure also provides us a logical entity which we are calling it as Azure SQL Server. So if I look at this, got a few points about the Azure SQL database. So SQL database is a relational database service that is used by the developers to create applications in the cloud. We do not have to worry about anything to maintain the server. We simply need to start from the database. It is a platform as a service. We already talked about it. Now Azure database is always running with the stable version of Azure SQL Server database engine. The point which we need to understand here, in previous setup, the upgradation of the database engine and the operating system is our responsibility. But here Microsoft is going to take care for us. And it always runs with the latest and stable version of database engine. So that's the benefit we are getting in this setup. Now also Microsoft handles all patching and updating of the SQL and operating system. Since we know we only need to create database and tables, however, we still need to understand that it works as a logical entity. So Microsoft is providing us a logical entity and we are calling it as Azure SQL Server. We do not need to manage anything for this Azure SQL Server. At the time of creation of database, we simply need to fill the information like, yes, this is going to be my Azure SQL Server for this particular database. Let's understand few points related to Azure SQL Server as well. As said, it is a logical entity which hosts the DB engine application like SQL. We need to remember it is hosting the DB engine application like SQL, but we are not maintaining this particular Azure SQL Server. To create Azure SQL database, as we know, we must need Azure SQL Server because we need to tell the Microsoft, okay, this is a logical entity of my Azure SQL Server where I am going to host my database. Now Azure SQL Server can be created at the time of creation of SQL DB. As I told, all we need to start from the creation of the database. And while creation of the database, we can create Azure SQL Logical Server. Also, this is for the first time. Let's say if I'm creating another database, then I can use the same Azure SQL database as a logical entity. So now one Azure SQL Server can hold multiple SQL databases. Lastly, Azure SQL Server is a parent resource. So since it is a logical entity, and if somebody deletes that entity from the Azure portal or from the Azure, then it will also delete all the database which is residing in that Azure Logical SQL Server. So it is important to keep this point in mind. So these are few points which we talked about Azure SQL Database and Azure SQL Server. I hope this explains and it also clears the difference between how the SQL database works in an on-prem environment and how it works in an Azure cloud environment as a PaaS solution. Now it is time to go to Azure portal and see how we can create Azure SQL database. Let's go to the Azure portal. We are in our Azure portal, and here we are going to see how to create SQL database. As we know, before creating SQL database, we need to create SQL server. In one SQL server, we can host multiple SQL databases. However, SQL Server is just a logical entity. So let's go and first create SQL Server. To create SQL Server, you need to type here SQL and it will give you both options, SQL Database and SQL Server. So if I choose SQL Database and if I hit on create, then here you can see the option server. So it is also asking the option to create the server at the time of creation of SQL database. So we can create here as well. Also, we can create our SQL server first and then we can switch to SQL database. So let's create a SQL server directly and also see some information about it. So we went into the creation of SQL Server. You can see the web page has opened for us. It is asking for us to provide some information. So we are simply going to choose our subscription first and resource group. Now it is asking to provide the server name. So let's say if I provide the server name as 591 lab db server. Okay, so it says your server name can contain only lowercase letters. Fine. So if I call it like this, then it should work. Yes. So 591 lab db server is going to be name of our server, and we are keeping the location as East US. Now it is asking us to provide the authentication method. So this authentication method is important because here we are going to tell like how anyone can connect to the databases. So for this video, we can use SQL authentication. However, we also have the option to use Microsoft Entra only authentication. So if you have already a Microsoft Entra ID set up in your place, then you can use this option. And if you would like to use both kind of authentication method, you can use this option as well. For this video, let's talk about let's use SQL authentication. I'm here going to type the name of the admin. So I'm just typing SQL admin and then I need to type the password. Okay, the password and the confirm does not match. Let's retype. Okay, now it matches. Hit on next. So it is asking, do you want all your Azure resources connected to access this server? So you can keep it yes if you would like to, and if you keep it no if you don't want to. So as of now, we can keep it yes. Go to security, can go to the additional settings, and here it is asking if we would like to enable Microsoft Defender. But as of now, we are not choosing this option. So let's go and simply hit on review and create. So, and also you have noticed here, we are creating a server, but it has not asked us to provide any CPU or memory or any storage or disk device, because this is not just like a regular server. This is a logical entity. So inside this, we are going to create our database. So this is why, as I mentioned earlier in the PPT, like this is a logical entity which is completely managed by the Microsoft itself. We do not have to choose what operating system we need it. We do not have to choose what DB engine we require. It's all being managed by Microsoft itself. So let this deployment complete, and then we will go and see how to create the SQL database. So now the deployment is completed. Let's go to resource. So we are in our SQL server, which we have created just. In this page, if you look at the left side, then you can find SQL database. So if I'll click on this, then you see there is no database found, because as of now, we have not created any database. We have only created SQL server. To create the database, we can simply go to overview and create the database directly from here also. Also, we have the option to create the database separately by using here searching SQL database. For this lab, let's go and create the database here. Now you can see few information which is already filled up here because we are opening this page from the SQL Server logical entity. Now what we need to provide here is the database name. So I am just going to type the database name. Okay, now the next is asking whether I would like to use the SQL Elastic Pool or not. SQL Elastic Pool is a separate topic and we are going to cover it in a detail later in this video. So as of now, let's keep it choose no. Then it is asking for the workload environment. So Microsoft offers two kinds of workload environment. One is development and one is production. If your workload environment is going to deal with the production environment, you should choose with the production environment. Otherwise, you can go with the development as well. So if I choose the development option here, and here I can see compute and storage, the next part. Let's click on the configure database. And here we need to understand few things. We have service tier and we have compute tier. So if I expand the service tier, then I can see we have vCore-based purchasing model and DTU-based purchasing. So it is important to understand these tiers and these purchasing models in detail. For that, let's go to PPT and understand them in detail first. Then we will come back here and resume the creation of our database. Okay. So as we have just seen in service tier, we have DTU model and then we have vCore model. So DTU model or DTU stands for Database Transaction Unit. It is a model where we are basically combining the power of compute and the memory and the storage together. And every single transaction is going to utilize the resource as combined. However, if I talk about the vCore model, in the vCore model, we have a separate vCore and separate memory for our databases. So DTU is basically all about bundling the compute power, storage and input-output resources, and it is best for customers who want simple pre-configured resource option. However, the vCore model is basically providing us the option of scaling of compute and storage and input-output resources. It is best for the customers who need more flexibility control over the resources which is running behind the databases. Let's switch to this slide and talk about this vCore-based and DTU-based. So now we understood what are these two different purchasing models. In these two purchasing models, we are getting three categories. For the vCore-based, we are getting general purpose service and business critical and hyperscale service. The general purpose is again which is designed for the common workload and it is a budget oriented as well. If I choose the business critical service tier, then this is designed for the high transaction rates, which means if I have an application where the transaction rate, which means input and output, read and write operations are very high and that are critical in nature too, then I should use this option business critical service tier. Along with this, we also have hyperscale service tier. In this service tier, we can see we are getting the great flexibility and high performance with independently scalable compute and storage resources. So we'll see it on the portal as well. Now we are coming to the DTU based purchasing model, and in this purchasing model we are also getting three different tiers: the basic tier, standard and the premium. So the basic tier is again for the less demanding workload. So if I compare with the vCore based, so it is pretty much the general purpose service. The standard tier is again for the common workloads and it is a budget oriented as well. And the premium service tier is where we are getting the high transaction rates. Again, we can use this premium service tier of the DTU based purchasing model if we have any high transaction related application. So the difference between vCore based and DTU based is that for the DTU based, we are combining the resources, and in the vCore, we are getting the separate resources. So that's the difference between vCore based and the DTU based. Along with this, we also need to understand one more point, which is compute tier. So along with the service tier, we also have to decide the compute tier. So for service tier, we understand we have two purchasing model. One is vCore-based and another one is DTU-based. So for vCore-based, we can get two computing tier, the provisioned computing and the serverless compute tier. However, for the DTU-based purchasing model, we can only get the provisioned computer tier. If I look at the provision computer tier, then it basically provides a specific amount of compute resources that is continuously provisioned independent of workload activity. And if I talk about the serverless computer, then we are getting the range of compute resources. So now let's time to switch on Azure portal and see the difference between them. So we are again back in our Azure portal where we were creating our SQL database, and let's understand and visualize few differences here. If I click on the service tier, then again, as stated in the PPT, we are getting the general purpose, hyperscale and the business critical. So if you can choose here, if I go with the general purpose and if I scroll it down, it is asking you, would you like to make this database zone redundant? I'm getting option yes or no. So if I choose the yes, my database is also going to be copied into different zone. If I choose the hyperscale, I'm getting the same option. If I choose the business critical, I'm getting the same option. However, if I choose the DTU based, then you can see I'm not getting the option of zone redundant here. If I choose the standard, I'm not getting. But if I choose the premium, then I'm getting the option of zone redundancy in premium. So in the DTU option, we only get the zone redundancy with the premium tier. If I choose with the DTU again in the basic, so you can see here, I'm not getting the option to choose any virtual core or any memory. But if I go with this general purpose vCare, you can see I'm getting the option to choose my hardware configuration. So if I click on change configuration, you can see that much core I can get, that is the maximum memory I can get, and that is the maximum storage I can get. So I have multiple options to choose from here. So this is why we are talking about in the vCore-based purchasing model, we have the option to choose our own compute, our own vCore and our own database, storage. However, when we switch to the DTU-based purchasing model, it is not giving us that option to choose the vCore, memory or the storage. We simply giving us like, yes, this is the maximum data size you are getting. Here, we can increase it as well. As of now, I think for the basic, it's only giving us the 2. If I'll switch to the standard, then I can get different options. Like maximum is, I believe, 2 or 10. Okay, maximum I can get 250 GB of storage, but it is only giving you 10 DTU for us example. So you can see here, the more DTU I'm going to increase, the more cost is also going to be increased, and more DTU means I'm getting more power related to compute and storage. So I hope this pretty much explains the difference between the DTU and the vCore. One more point which I would like to discuss about this compute tier. So provision and serverless. We just talked about if I choose the vCore based purchasing model and any of these options, we are getting two compute tier, which is provision and serverless. But if I choose to DTU, then I'm not getting any provision. If I click here in the premium one, I'm not getting any option here. So let's understand in the general purpose. So the compute tier has two options, the provision and the serverless. Let's talk about the provision. Now you see, the moment I entered or chose the provisioned one, you can see I am simply getting the option to choose what vCore and what maximum memory and storage I can choose it from here, which means I need to decide how much virtual core I need, how much memory and how much data storage I need. But if I go to the serverless, now you can see it is giving the range of serverless, which means I can decide how much minimum server vCores I need and how much maximum vCores I need. Benefit of using this serverless option is that When you choose the minimum vCores, so let's say for example, if I choose, let me increase, if I can increase it. Okay, so maybe I'm just choosing the general purpose, so that is why it is not giving me the option. But here we have the benefit like 0.5 vCores, and I can choose the maximum vCore. So for example, if I'm choosing the maximum vCore 6 and the minimum vCore is 0.75 vCore, so I only need to pay for the minimum, which is 0.75, and I will only pay for my maximum vCores when it is utilized. So if it is not utilized, I only need to pay for this minimum vCore. But if it is utilized and which can go up to 6 vCores, then I need to pay for that period only. So that's the benefit when we choose for the serverless option. We also get one option which says auto pause delay. So let's say there is a certain time frame, or there is a certain time where my database is not going to be used at all, and I don't want to pay for that. Then I can use this option auto pause delay, which is comes under only the serverless compute tier. And this serverless compute tier is only a part of vCore-based purchasing model. So I hope I have explained all about the vCore-based purchasing model and DTU-based purchasing model. So let's go for the DTU-based purchasing model, and as of now hit on apply. Then later we can see the next option we have is the backup and storage redundancy. So as I mentioned earlier, backup is something which is taken care by the Microsoft. All we need to do here is to tell Microsoft, I would like a local redundant backup, zone redundant backup, or geo redundant backup. For example, for this video, we can go with the local redundant backup. So let's click on networking. So let's not choose anything here. Just keep it as it is and just hit on next, review and create. So it is going to give me the final summary, like how my database is going to look like, and then hit on create. So this is going to take some time. So you can see here the deployment is initialized, so it is going to take some time to create the database inside the server. Once this deployment will be completed, we will see and resume the lab. So you can see the deployment is running on now. We will just wait for it to complete and then we'll resume again. Now we can see the deployment is completed. This means the database which we have started to create is created now. Let's go and check. So let's go to another tab, and here just type SQL databases, and you can see this is the database which we have created, 591 lab db1. And if you go here, then in the overview you can see this is the server name is this 591 lab db server. So the server which we have created is 591 lab db server, and inside that we have this particular database. So the database creation is completed now. Now let's try to create a table inside this database. So to create the table inside the database, we need to go to query editor. So let's click on the query editor, and now it is asking for the authentication. So we need to provide our ID and password. So ID is already taken. So I'm just entering my password, and you can see the message says cannot open this server requested by the login. Client IP address is not allowed access to the server. So to enable the security, Microsoft basically already blocks the all IP addresses here. So we need to allow this IP into our server. It also says allow list IP on server 591 lab db server. So let's do one thing. Let's duplicate it and go to the server and allow the IP first. That is also a good point, because this is something which is going to provide an added layer of security. So let's go to SQL Server. This is our SQL Server, and to allow or whitelist the IP, we need to come into the networking section of the server. And here you can see we are getting the option add virtual, add your client IP address. So it's already picking up. So let's click on this and hit on save. So its configuration is saved. Now if I go back to my SQL database and if I hit on refresh page, then let's see. Okay, let's provide the password one more time and hit on OK. And now you can see I'm getting into my query editor. So after enabling or whitelisting my IP address, I'm able to log in into my query editor. So here you have the option to execute the query. So we all know when we are talking about the database and the table creation and management of the table creation, we need to must have an understanding of the SQL queries. So to create a SQL query, I have just written down one command or one query. You can call it like create table student. So what we are going to do, we are going to create a table called student. In that, we are going to fill this information: first name, last name, age, and roll number. So let's try to run and see if it works or not. So if I click here and if I run here, you can see here query succeeded. And I have this first student name, then last name, and the age and the role. So if I click on the table, then I can see the dbo.student table is already created. So let's create or insert some data inside this table. Okay, to write or insert the value into the table, we need to write one more query. So either we can delete this or we can start a new query. So let's delete this. To insert the value inside the table, we need to type another query. So which should be insert into and then table name student. I can type like student here and just mention first name, then we have last name, we have age, and then we have roll number. Then we need to type values, and let's say the first name should be John, last name should be Hopkins, then we can go with the age should be 19 and roll number should be 1. Now if I execute this query, it should create or insert this data into my table. To view that, I can simply type select asterisk from student. And if I select this and let's remove this, for example. So now you can see I'm getting the data from my John Hopkins 19 and roll number 1. If I execute the same data again and let's change the name one more time. So this time I'm just going to type Thomas and just the second name is Thornton. Age should be, let's say 21 and roll number should be 2. So if I run this query, it will again the another set of the data into my table, then select asterisk from student. If I run this, I'm getting the table or data here as well. So this is how we have seen how to create table inside the database. First we created our SQL database, then inside that we created table, and then after that we created or we inserted some data into this. So this basically talks about the SQL database and SQL DB. Now there is one more point we need to understand and talk about, that is elastic pool. So let's go to our PPT and first understand what is elastic pool. Then we will come back to this Azure portal and we'll see how elastic pool works. So we are in our PPT And let's understand about the Elastic Pool. Elastic Pool is an option which helps us to utilize the resources which we buy for our database. We have two purchasing models, vCore-based and DTU-based. In both cases, we purchase resources for our databases. However, it is not mandatory or important that our databases are using our resources all the time and with their all capacity. Most of the time, we can see the resources are lying unutilized or underutilized. In this scenario, Azure offers the concept of Elastic Pool. Look at this chart here. In this chart, you can see we have one database and the resources are pretty much unused or underutilized most of the time. When we club four databases with this pool, then we can see the resources of are being utilized and all the four databases can utilize the same resources. So this basically saves us from buying dedicated resources for each database. So Elastic Pool is a concept where we can club multiple databases to use other dedicated resources which we have purchased. So let's look at some viewpoints here. So Elastic Pool solves the problem by ensuring the database gets the performance resource they need when they actually need them. It is a simple and cost-effective solution for managing and scaling multiple databases. And also it is important to note like these pools are well suited arrangement for the large number of databases with specific utilization patterns. So if you have a database which has a very critical application or operation and it uses a lot of resources frequently, then this option may not be useful. However, when you have very large pool of databases and all those databases are not that much active or operational, then of course we can choose the option of SQL Elastic Pool. I hope this explains what is SQL Elastic Pool. It's time to go to Azure portal and see how to create Elastic Pool. We are in our Azure portal once again, and this time we are going to create a Elastic Pool. So to create Elastic Pool, we can create a SQL database from the SQL server as well, or we can independently create a Elastic Pool. So if I talk about here, Elastic you can see I'm getting the option SQL Elastic Pool. So I can create it from here itself. Head on create Elastic Pool. Now you can see it is again giving us the option to use the subscription, then resource group, and provide a name of the Elastic Pool. So I can simply mention like 591 lab Elastic Pool, and it is asking me to choose the server because Elastic Pool is going to need a server. So I'm just going to use the same server, and now it is asking me to choose the compute and storage tier. So if I click on this choose compute and storage tier, then you can see I'm getting these options. So if I switch to DTU-based model, which is the basic one, you can see now the DTU has been changed to eDTU. eDTU stands for Elastic Pool DTU. So if I choose the DTU, then I'm getting this option like 4.8 GB of the storage, and I'm going to get 50 DTUs. So I can hit on apply. One more point which I would like to draw your attention here. The price of the eDTU is actually higher than the normal DTU because this is the shared pool of resources. So that is why this price is higher than the normal DTU. So, but the restriction with the normal DTU and the eDTU is that for normal DTU, you have to purchase DTU for every database. But for eDTU, you do not need to purchase the resources for every database. Let's go and hit on apply. Then next security, then keep all the settings as it is and hit on create. So it's giving me, it's running the validation, and after that it is going to run the deployment. So let's wait for the deployment to submit and then it will get created. We can see here it's deploying now. So let's wait for it to be completed, then we will resume. So the deployment is succeeded. Let's go to resource. And this is our SQL Elastic Pool. You can see here option to configure. Okay, so if I would like to increase the resources for my Elastic Pool, I can do it from here. Now let's go back to my SQL server and SQL databases and try to create one SQL database. Or we can do it from the SQL server also. Create database. And this time I'm just going to create a database again, 591 lab db2. And this time I would like to use the Elastic Pool. Hit on yes. The moment I chose yes, it is asking me to use the Elastic Pool. So if I have already created, I can use this, else I can create the Elastic Pool from here as well. Again, I can choose which kind of backup I need, then no need to do anything, then go to keep as options as it is and hit on create. So this database is going to use the resources from the Elastic Pool itself. Meanwhile, this is getting deployed. Let's go back to the another window, and here I'm going to take you to the SQL server, and this is my SQL database. So that's my SQL database. Okay, now you can see this is not a part of the Elastic Pool, so it's giving me the option no Elastic Pool. If I click on it, I am coming, it's basically taking me to the SQL server, and it is not giving me the option to show any Elastic Pool here. So this is how you can verify if a database is a part of Elastic Pool or not. Now, if I'm coming back to my database again, here you can see this is the pricing tier basic and this is the Elastic basic. So my second database is a part of the Elastic basic. Now if I create a third database, and go to resources, go to home, then go to SQL databases and try to create a third one. So if I say 591 lab db3, everything is selected there. Again, yes, I would like to use the Elastic Pool, and it is giving me choose the Elastic Pool again here. And this time I'm not choosing anything here. If you see the difference, when we were not using the Elastic Pool, if I hit on no, then it is asking me to provide the compute and storage detail. But the moment I'm going to choose the Elastic Pool, it is not giving me the option, because the compute and storage resources are basically configured with the Elastic Pool. So no matter what database I'm going to use, if I'm going to create that database inside this Elastic Pool, it is going to use the resource from that Elastic Pool itself. So that's basically saves us the cost of choosing compute and storage for each and every database. I hope this explains about SQL Elastic Pool. Now it's time to go and review some questions related to the exam preparations. So let's go to the PPT and review some questions. So here is our first question. First question says, which Azure service is used to provide a scalable, fully managed relational database service? Options are Azure Cosmos DB, Azure SQL Database, Azure Database for MySQL, and Azure Data Lake Gen 2. So if we talk about scalable and fully managed RDMS or relational database service, then SQL database is our first choice. However, look at other options. Azure Cosmos DB is a non-relational database service. It's a no SQL database service, so it cannot be our answer. Then Azure Data Lake Gen 2 is a big data solution for the cloud So it cannot be our answer. Then we are left with Azure SQL Database and Azure Database for MySQL. So here we are talking about fully managed relational database service. So MySQL is basically not fully managed by the Microsoft. So the obvious answer here is Azure SQL Database. Let's move to next question. In this question, we are designing a SQL database solution. Fine. And the solution will include 20 databases. Okay, that's a good number of databases we need to host. And all 20 databases, that will be 20 GB each. Fine enough. So, and they have varying usage pattern. Okay, that's also a point to be noted. You need to recommend a database platform to host the databases. And the solution must meet the following requirements. Okay, the requirements are: the solution must meet SLA or service level agreement of 99.99%. Compute resources allocated to database must scale dynamically. And the solution must have reserved capacity and compute charges must be minimized. Look at the options. The first option says 20 instances of Azure SQL Database serverless. So here we are talking about the less charge or the cost to be optimized. So if we go with this option, the cost is not going to be optimized or cost is not going to be minimized. Okay. Then the second option says a database of a Microsoft SQL server that runs on an Azure virtual machine. We can do this option, but this is not completely managed by the Microsoft because only the virtual machine is going to be managed by Microsoft. And the SLA of 99.99% is not going to be achieved with this option. The third option says an elastic pool that contains 20 Azure SQL databases. This seems to be a promising option because it says elastic pool that contains 20 Azure SQL databases. So we have seen in our lab when we were creating SQL databases, we have the option to create elastic pool. So elastic pool is actually a pool where we can club multiple databases to use the purchased resource we have it for our Azure SQL databases. So this will also provide us the SLA, which is 99.99%, and it is also the compute resources allocated to the database must scale dynamically. So this should be our answer. Yes. Now let's move to next question. You have an on-premise application that consumes data from multiple databases. Fine. The application code references database tables by using a combination of the server, database, and table name. Okay. Now you need to migrate application data to Azure. To which two service can you migrate the application data to achieve the goal? So basically there is an application which is an on-premise environment, and that application has a data, and that data is basically a combination of database, server, and a table name. We understood that. Now look at the options: SQL, Azure SQL Server on Azure Virtual Machine, Azure SQL Managed Instance, Azure Cosmos Database, and SQL Server Stretch Database. So last two options are not possible because Azure Cosmos Database does not support the relational database and SQL Server Stretch Database is nothing. So we have left with two options, which is SQL Server on Azure Virtual Machine and Azure SQL Managed Instance. So let's see. Yes, this is our answer. Okay. The next question says you need to design a highly available Azure SQL database that meets the following requirements. Failover between replicas of the database must occur without any data loss, and the database must remain available in the event of a zone outage, and the cost must be minimized. So there are three requirements we need to think about. Okay, look at the answers. We have Azure SQL Database Premium, then Azure SQL Managed Instance, General Purpose, Azure SQL Database Standard, and Azure SQL Managed Instance Business Critical. In our lab, we have seen if we go with the standard or managed instance, we are not going to get the option of zone outage. So zone redundancy is an option available with premium and business critical only. So we also have a third factor to consider here. The cost must be minimized. So Between Azure SQL Database Premium and Azure SQL Managed Instance Business Critical, the Azure SQL Database Premium is the most cost-effective solution for this question. That's our answer. So this is going to help us to fix this solution. Let's move to the next question. You have an app named App1 that uses two on-premise Microsoft SQL Server database named DB1 and DB2. Now we plan to migrate DB1 and DB2 to Azure. Fine. And we need to recommend an Azure solution to host DB1 and DB2. So basically there are two databases which is on premises. We need to migrate to Azure and we need to figure out which solution is going to help them. First, we also have a requirement that it should support server-side transaction, which is fine, and minimize administrative effort to update the solution. Okay, look at the answers now. To Azure SQL database in an elastic pool. So this option elastic pool is not feasible here because we only have two databases. So when we have large set of databases to host, then elastic pool is obviously our choice. But here we are only dealing with two databases, so I don't think this should be the choice. Let's move to the next options. The database on the same Azure SQL managed instance. Yes, two databases on the same Azure managed instances would be our choice. However, let's look at other two options. Two databases on the same SQL Server instance on Azure virtual machine. We can go with this option, but it will not minimize the administrative effort. We have to do a lot of administration in this option. Last option says two Azure SQL database on different Azure SQL databases server. We can go with this option, but again, it is going to increase the cost and we do not need to do that. So here answer should be two databases on the same Azure SQL managed instance. So this is the answer. Let's move to the next question. Okay, you have 100 servers that runs on Windows Server 2012 R2 and host Microsoft SQL 2012 R2 instance. Fine. The instance hosts database that have the following characters. Okay, so basically we have 100 servers of 2012 R2. Okay, the largest database is currently 3 TB and none of the database is going to exceed more than 4 TB. The stored procedures are implemented by CLR and you plan to move all data from SQL Server to Azure. Okay, so all of these servers are basically going to move to Azure. Now we need to recommend Azure service which is going to host the database. And the solution must meet the following options. Whenever possible, minimize the management overhead for the migrated database. Okay. Minimize the number of database changes required to facilitate the migration and ensure that users can authenticate by using their active credentials. Now look at the options. Azure SQL Database Single Databases, Azure SQL Database Managed Instance, Azure Database for MySQL, and SQL Server 2016 on Azure Virtual Machine. So the obvious answer is Azure SQL Database Managed Instance because we are talking about here more than 100 servers. The Azure SQL Database for single database is not going to work here. MySQL is again not going to work here. And SQL Server 2016 on Azure Virtual Machines, we can do that option, but it will not minimize the management overhead. So our answer should be Azure SQL Database Managed Instance. This brings us to the end of this video. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is the critical to mastering any new skill. So review the course content, keep practicing with 591 Lab help and support. If you have any question or concern, please do not hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Before signing off, we have our humble request to like this video, subscribe our channel and hit the notification bell. Have a great day. Thank you.